Today we're going to talk about section 9.1, and 9.1 is basically looking at identifying quadratic functions. And quadratic functions look like what you see right here, which is also called a parabola, and very different than what we've learned in the past. In the past we were talking about linear functions, and now we have one that is curved. So just a couple of basic things that we'll see with parabolas. You can see that we have this thing called the axis of symmetry. It's a vertical dotted line, which usually you don't really show on the final graph, but it can be a good point we can use to help us graph these things. But on that axis of symmetry is the vertex, and that's always a very important point because on your parabola it's the turning point. It's where it turns from one direction to the other. But basically it's on that axis of symmetry, and on your parabola, if it opens upward, which this one does, we'll talk about that in a second, it is the lowest point of your graph. Okay, so that is the vertex. And then you can see this particular parabola has x-intercepts. It won't always have x-intercepts, or it might only have one. We'll talk about that in a couple lessons. But this one has two, and then you can see this one also has a y-intercept. So we'll talk about that stuff a little bit later. Vertex right now is really the main thing we want to look at. So as I had mentioned, you can have a parabola that doesn't open upward. So in example B, you can see that we have a parabola that opens downward and continues downward forever. In example A, it opens upward just like the first one that we looked at. So this leads to another topic, a very simple concept. All quadratic functions are going to have a maximum or a minimum value. So looking at A, this has a minimum value, and that's at 2. Y equals 2. And the vertex lies on that minimum, -3, 2, so that is the point right here. And then on example B, we have a maximum value of 5 at y equals 5, and the vertex is at 2, 5. So kind of a backwards concept when you think about it. If a quadratic function or a parabola opens upward, it's going to have a minimum. If it opens downward, it's going to have a maximum, which is a little bit backwards. But just got to think about that a little bit, and it'll all come and make sense. So as far as what these look like in equation form, we've been working with equations that look like this. We've been doing some factoring and things like that, which will come into play in this chapter later. But basically a quadratic function will always have an x squared variable involved. Okay, and you'll see there's a, b, and c. A, b, and c are just numbers, okay, real numbers. And remember, then x would be a variable and y would be a variable. So you can see here on the bottom in red I have if a is greater than 0, meaning a is positive, the parabola will open upward. So if we had something that looked like this, y equals 2x squared minus 3x plus 1. If we look at that value, that's a, that is positive. That tells me that parabola will have this kind of shape where it opens upward. If a is less than 0, meaning it is negative, so let's say it looked like this. Remember, if you don't see a variable, or sorry, not a variable, a number, there's a 1 there, so it'd be -1x squared, maybe it's just plus 2 or something. Because this is negative, it's going to open downward. Okay, so pretty easy to tell based on the equation what's going to happen. The only time you'll need to be careful is if they had something like this. Remember, y needs to be solved for. You have to get your dependent variable all by itself. So y equals, and we'd have to subtract 2x squared over. And now this is negative, so it actually opens downward. Okay, so that's one little thing that can be a little bit tricky. All right, lastly, looking at a graph and then kind of domain and range of a quadratic function. At this point, I'll show you just the table method. We will very soon get into different ways of graphing these, faster ways, more accurate ways, more so faster. This is still accurate. But anyway, what I like to do is check 3 different values, -1, 0, and 1. And I always check 0 first because it's always the easiest one. So remember, you're putting in stuff for x. So I'm going to put 0 in here. 0 to the second is 0. 2 times 0 is 0. And then 0 plus 1 is 1. So 0, 1 is a point. And then I'm just going to put in my other values and see what we get for an output. So if I put negative 1 in for x, that's 2 times negative 1 to the second power plus 1. Order of operations, we have to do the power first. So I got to do negative 1 to the second, which is negative 1 times negative 1, which is positive 1. So really we have 2 times 1 plus 1, or 2 plus 1, which is 3. So negative 1, 3, which is this point right here. And then if I put 1 in, I'll go 2 times 1 to the second plus 1. 1 to the second is still 1. It's 1 times 1. 2 times 1 is 2. Plus 1, we get 3 again. So 1, 3. Alright, so we get kind of a shape that looks like this. Not a very good curve there by me, my artistic abilities. But we have a parabola that opens upward. And again, we won't always have a vertex right on that y-axis, which is why we'll show you different ways to graph in the near future. So lastly, looking at domain and range. Domain of all quadratic functions is all real numbers. Because remember, domain talks about your x values. This thing will continue going outward forever in both directions. Slowly, but it will. So all x's will be a part of your domain. Range is the only thing you'll have to look at then. So that is where your minimum or maximum will come into play. So this has a minimum value of 1. So that tells me y can be anything greater than or equal to 1. Okay? So domain will always be all real numbers for quadratic functions. Range will vary depending on where your graph is located. All right, that is all I have for section 9.1.